With this video, we would like to present a concept to identify any tokens out there. You might know that tokens are not easy to clearly and uniquely identify because forks might occur, there are multiple DLT networks out there, and so on. So this makes it difficult to identify tokens. And our approach by the ITSA is to uniquely identify tokens across blockchain systems worldwide and also resilient to forks. It's joint work by Philipp Sandner, Johannes Pfeffer, Konstantin Ketz, Niels Bundi, and Thomas Faber. As an executive summary, let's quickly present what we are doing. So what we are presenting is the so-called UTL. We call this the Uniform Token Locator. It's an idea by the ITSA Association. ITSA is the International Token Standardization Association. And the UTL works as follows. You see it here, that the UTL consists of the genesis hash of a distributed ledger, the post-fork hash after a fork occurred, then also the recent hash, and potentially, if needed, a smart contract address and also the token sub-address in case we have non-fungible tokens. This is then mapped, if needed, towards an ITIN, just having 9 characters. The UTL is clearly identifying tokens uniquely, but it's very long. It has more than 200 characters, and the ITIN just has 9 characters. So this is also memorizable for human beings, whereas the UTL is primarily there for interacting with machines, algorithms, and IT systems. The basic thought we apply here is that we already have the URLs out there. That's called Uniform Resource Locator. And the URL consists of a protocol, the subdomain, a domain, and a top-level domain. You see it here in dark blue. And it can also be shortened with a so-called URL shortener, for example, like bit.ly. So the same way you can have a very long URL to identify websites, you can shorten them down to a very short memorizable link. And the same way we also identify tokens with the UTL and then potentially shorten them down to a 9-character ITIN. That's basically the executive summary, and I will now go into more detail with the following slides. So who are we? The ITSA is an international token standardization association sitting in Berlin, and we are, from what we are doing, we aim to identify tokens with the so-called ITIN number. That's an international token identification number. Then we are also classifying tokens. We have classified so far 600, 700 crypto assets according to 4 various dimensions, which allows them to do analytics with them. And finally, we provide a token base. That's a database for analyzing tokens, market data, and so on, in compliance with our ITC framework, such that you can analyze, is the segment of utility tokens increasing or shrinking? Is payment tokens basically getting more and more important, and so on. We are engaged in multiple standardization bodies, for example, the DIN, ISO, and other ones. We are working together with research institutes and academia around the world. And we also have multiple company relations for token market providers, token market initiatives, and also financial market data providers. So where are we coming from? What's the point of departure? So first of all, let's argue that there are millions of tokens in the future. And to really explain this, we first have to see that there are right now tons of financial instruments out there, many securities, and of course also currencies in a world without blockchain. In a world without blockchain, some of the currencies and some of the financial instruments, they will at some point of time run on DLT networks or also platforms such as cryptocurrencies. And then we might have the euro or the US dollar on blockchain-based system. We might have security tokens, and we already have a bunch of utility tokens and payment tokens. For example, Bitcoin is in our definition a payment token. But in the future, we might have many more tokens out there. They might be fungible or non-fungible. Some of them might be traded in capital markets. Other ones might not be traded, but one is still common here. The tokens need to be identified such that, for example, in legal contracts, we know what tokens are we talking about. So why is referencing tokens in contracts needed? Here is an example. You see here a random contract for purchasing tokens. There is a date included, there is a US dollar amount included, and so on. So this is a token purchase agreement. And you see here in yellow that there is an Ethereum address noted, but it's unclear whether this Ethereum address is applicable for the Ethereum network or for the Ethereum Classic network. So this, as you see it here, is not uniquely applicable, is ambiguous. So you see here that writing such addresses manually in legal contracts is providing not a seamless integration. So interaction with other tools, algorithms, devices, and machines are difficult. It's not fork resilient because it becomes ambiguous through forks which happen afterwards. And it's inefficient because it requires additional effort to copy this piece of text in other systems, for example, accounting systems. So what we propose is the Uniform Token Locator, as you can see it here. It's efficient because it does not require additional effort to be used in other systems because it's unique, so it can be easily used in accounting systems. Next, it's fork resilient because it does not become ambiguous over time. And it allows for a seamless integration, for example, with other tools, algorithms, devices, and machines. For example, you can also code the UTL in a QR code. You can see this here, and the QR code can be part of an appendix of the contract. So imagine you can take out your cell phone, you scan the QR code. It doesn't work right now, but it will in the future. You scan the QR code because it's at the appendix of your contract, and then the browser of your cell phone directly indicates to you whether the subject of the contract, like a token on something, might have been transacted to you or not. Yeah, this is what we mean with seamless integration, which is not possible so far. So again, we have a Uniform Token Locator here as a QR code. It's efficient, fork resilient, and it allows for a seamless integration. Another example why we all need this, like that's part of the motivation, what we are doing here is that we would like to reference tokens also, for example, in the public. So imagine this kind of advertising out there. It's not real, it's just for illustrative purposes. So imagine this advertising somewhere, you drive by a car, and then you read here that you can support exactly this school on the photograph, which is in another country, and you can support this school with exactly €5 by scanning this QR code. And if you scan it right now with your QR code, then €5 are transferred from you to exactly this school in the other country. And again, you need to clearly identify tokens because this school would have a wallet address for receiving money, but you need to clearly identify what exactly is the wallet address on Ethereum, for example, for this school, especially when forks are occurring, not that money is flowing where you don't want to have it. And again, here we need the UTL. It's efficient, fork resilient, and it allows for a seamless integration. So what is the UTL we have been talking about so far? So as set out in the executive summary, we start from the URL, which we all know, which is out there since years. So the URL is an identification mode to identify websites out there. It includes the protocol, the subdomain, a domain, and also a top-level domain, such that it identifies any web page out there. It can also be used in shorteners, such that you have shorter URLs, which are then pointing towards this longer form URL. And we apply the same structure, for example, for identifying tokens. We call it the UTL, the Uniform Token Locator. It again consists for opening up the data in a browser. It consists also of the protocol, but the key point here is written in bold, because to identify the distributed ledger, you need the genesis hash, the post-fork hash, and also the recent hash. And if needed to identify the token on top of a distributed ledger, you might also need a smart contract address. And in case we have non-fungible tokens, we also might need a so-called token sub-address. Of course, the post-fork hash would potentially be enough to identify a fork, but the fork could also lead to subsequent forks as time passes. Therefore, we also need to have the recent hash. That's the high-level definition. We are providing more material out here to really justify why we need these three hashes to identify very clearly the distributed ledger we are talking about, plus the token which is sitting on top of the distributed ledger. That's a very long address here. It might be human readable. It might be machine readable, but it cannot be easily memorized by human beings. Therefore, we need to have a shorter version, which we propose as being the ITIN. The ITIN has 9 characters and is basically assigned to a long UTL, which might have 200 and more characters. So what are we doing here exactly? So what you see here is, for example, that the Bitcoin network is having a Bitcoin protocol such that the Bitcoin is basically as a token emerging. And this Bitcoin is basically assigned with an ITIN from us. In case the Bitcoin net protocol forks, then we have the Bitcoin Cash network emerging with an own protocol. And the token is called, for example, Bitcoin Cash. And again, there is another ITIN assigned to it to clearly identify this token. In case we have security tokens in the future, for example, we have the Apple stock, then the Apple stock might be identified with an ISIN number or, for example, also with a FIGI number. The Apple stock would be tokenized to let it run on a distributed ledger network. It can be, for example, the Ethereum protocol, such that we arrive at a tokenized Apple stock. And again, this would have an ITIN number. But the Apple stock could also be tokenized on the Stellar protocol, such that it would be another type of tokenizing the Apple stock with another ITIN. Yeah, everybody knows Tether, I guess. So that's the US dollar on blockchain. From a project name, it's just the Tether project. But if you dig a little bit more deeper, we will find out that the Tether project has multiple tokens and would therefore need multiple ITINs to clearly identify which tokens are we talking about. Third, of course, currencies will also run on blockchain systems in the future. So here, for example, we have the euro. It's tokenized, for example, on the Corda protocol. And then a euro-backed stablecoin is emerging as basically money on blockchain system. And again, an IT number would be required for this. And in the future, we might also have industrial machinery, which is tokenized, for example, on the Hyperledger protocol. Non-fungible asset tokens would emerge here. And again, we need to have the IT number here. So we have various possibilities why ITINs make sense, and we need to clearly identify any tokens out there. You can do this potentially with an ITIN number, but more interesting could also be the UTL framework, because this does not need to be assigned by human beings. It's automatically out there with the framework we are proposing. So the ITIN, to be really short here, for example, has 9 digits, and the first eight alphanumeric characters are basically letters or numbers. The first character cannot be a 0, and there are billions of combinations out there. It's assigned by the ITSA association, such that it's also fork resilient, because the ITSA might decide in discussion with the issuer to which fork this ITIN might point to in case forks of Ethereum, for example, take place. And there is a checksum to really prove that this ITIN number is consistent. It's basically here sitting at the position 9, and it's arranging, it's computed with a standard means of how to compute checksums. This is rooted now in the UTL framework. The UTL has been presented earlier. And again, here as a description, we need to have the genesis hash. That's the hash of the genesis block of the blockchain the token is sitting on, or the distributed ledger. Then we have to have the post fork hash. That's the hash of the first finalized block, which is complying to the protocol rules of the newest blockchain fork. And of course, this hash is generally unique. And it also controls for uncle, which are happening, because as written here, it needs to be compliant to the protocol rules of the distributed ledger network. Then we have to have a recent hash. That's basically the newest known hash of the chain. That's basically in Ethereum, the hash which has been produced 10 seconds ago. Of course, as time passes, the recent hash is getting older and older again, such that subsequent forks can occur, but these details we are outlining in a paper in written, because this would be too complex for this very short video. And in case we would like to identify tokens created, for example, by a smart contract, then we would need also the optional argument of the smart contract address, which would be required for non-native tokens. And in case we have multi-token contracts, for example, non-fungible tokens, NFTs, then a token sub-address would also be needed. As an example, you see here, for example, an ITIN on the lower half, A3, C4, and so on. That's easily memorable by human beings. And there is the long-term identification, which is efficient up to specific degrees fork resilient, and also unique across blockchain networks. That's basically the 4-line code which is seen here. This is not easy to memorize by human beings, but for machines, it can be used to also use in seamless other IT systems, algorithms, machines, and so on. So with this, we would like to close our presentation. My name is Philipp Sandner. I'm member of the ITSA, the International Token Standardization. In case you have questions, then please write us, please let us know. And we are looking forward to your feedback on our identification approach, and would be very happy in case you would get in touch with us at the ITSA. Some more words in case you are interested about the ITSA. Again, I quickly outlined it previously. We are focusing on 3 standardization projects. That's basically identification, classification, and also analysis. So the ITIN, I explained it previously, is a 9-digit alphanumeric identifier assigned to all types of cryptographic tokens. Then the second part is the ITC framework, where we have classified more than 600 tokens out there, 600 crypto assets, according to various different dimensions. For example, economic dimensions, technical dimensions, and legal dimensions. Of course, one dimension is the question whether a token is a security token, payment token, or utility token, but there are also other dimensions which are really making sense and are required. And we have the International Token Database, which is including all these data, including their classifications, like the classified tokens, together with the daily market data to run easy analysis. Another feature of the token base is that references to other third-party data sets are included, such that you can basically jump for analytics reason into other data sets, for example, on-chain analytics and so on. I have explained this previously. So as I said, ITSA is talking to multiple standardization bodies, research institutes, and academia, and of course, multiple companies, for example, market data providers, token market initiatives, and also market data providers to help them and basically jointly work on the standardization of token markets and token identification mechanisms. That's our members. So far, we have 200 international members. You see here that we have a footprint in Central Europe. We are changing this. We are becoming much more international. We already have members from South Korea and from other countries. But as you can see here, there is some footprint in Switzerland and in Germany. But as I said, this is changing quickly as time passes, and also this year. Yeah, thanks again. In case you would like to provide feedback, here's our contact data. Again, you also have a Twitter, website, and other things on the upper half of the slide. And we would be very happy to get your feedback on our identification approach. That's why we are outreaching with this short video. Thanks.